first keynote. Our first keynote is by Ahmed Hassan. He's a professor from the Queen's University, and he's the IEEE fellow and ACM 6 of the influential editor. Has many titles, and one of them is the NSERC DC fellow. NSERC, I happen to know, stands for National Science and Engineering Research Council of Canada. Also is the Canada Research Chair of Software Analytics, and he was a member of this new college of Royal Society of Canada. And this goes on and on. And Ahmed was recognized as the most prolific software engineering researcher in the past decade, which is he actually created this mining software repository conference and the community. I am part of the story. I was the PC member for the first version of MSR workshop while the Hassan Ahmed organized that. And Ahmed also recognized in many conference organization, PC committees, and also the served on the editor board of the many top journals. We all well known, like TSC and EMSE. Okay. Without further ado, I'll pass the token to Christoph. He'll play a well-recorded, prepared video by Ahmed for his keynote about his personal perspective on the empirical evaluation in software engineering research. Okay, and I think Ahmed also in the room, and he would like to prepare this play this video recording talk, but he can answer your questions after the keynote speech. Okay, and Kelly, can I pass the driving wheel to you? You chair the session. Now I'm driving back to home. It may take me about 20 minutes, and then I'll join the session again.
Okay.
Okay, thank you, everyone. See you.
Thank you for the introduction, and thank you for having me here today. Good afternoon, good morning, and good evening to everybody. Thank you for attending the talk today. Today, I would like to talk about kind of empirical evaluations in software engineering. And in particular, I'm going to take a more of a personal perspective, my opinion about the state of the world today in our field, and kind of what I believe are some of the challenges and some of kind of the steps ahead for our own community. So now, just to kind of put things in context, so we are today in a virtual conference. So, compared to a traditional conference, there's a lot of things we're missing, right? So we omitted that excitement of a loot bag, right? So you kind of go, when you go to the registration desk, you open it, you get that bag, and then when you sit, you start looking for the bag. Unfortunately, not that much happening right now in a virtual conference. Your best luck is either you're gonna get excitement from my talk, or maybe get a fortune cookie and crack it up and see kind of what luck you get in there. Another thing as well, when you talk about a virtual conference versus the conferences where the traditional conferences, you're missing that kind of activity, the physical activity, right? So always within our community, for many of you, that might be your first conference. We usually would have some kind of soccer game where so the excitement of chasing the ball around with all these grown-ups, okay, but dealing with the soreness next day. Many of you today are just sitting on your couches enjoying kind of my talk. I'm hopeful about that. Okay, so another thing about in-person virtual conferences is you don't need to deal at all with jet lag, right? You don't have to have any post-conference diet. So there's a lot of big differences. I think the key point is that personal perspective is missing in a lot of things, right? So, what I would say is let's take a chance, for the next couple of days to use some kind of in-person memory about either prior ICSMs or even other conferences you attend to give people as well that are attending a feel about the community itself, how friendly it is. I've been part of the ICSM community for many years, and I think there's a lot of great people in the community, and it would be nice as well for newcomers to realize that. Something that they're not going to get in a virtual setting. Now, so what is today's talk really about, and what is the context for this keynote? So, actually, we'll go back 10 years ago, and so 2010, and this was ICSM in Timișoara in Romania. At that time, Michael Lanza and the Marcus and Radu, the program co-chairs, came to me, Tom Zimmerman, myself, and Duru, and said, hey guys, you're the youngsters for the community. Why don't you sit down and tell us in a keynote that's divided across the three of you, what are the challenges for the software maintenance and engineering community? What are the things on the road ahead? You can think about it, maybe, so in many ways today's talk is another answer for that same email that I got over 10 years ago, right? So what are the challenges? Now, today I'm going to be talking about challenges that are not technical in nature. However, they're more about the state of our community and the steps ahead and where we need to go as a community. Okay, so it's been 15 plus years since the MSR community started itself. The MSR community some of it as well, kind of started up within the software maintenance community, okay? Looking back in the early days of MSR, the type of mining, the amount of effort we had to do was enormous, right? So there was no tools out there was no data out there, so you really had to get your hands dirty when you're doing that type of mining. Here's an example of a couple of MSR researchers doing they're working on their ICSE submission. So it was really hard work, as people would say. It was uphill both ways. Okay, now when you look at today, things are much easier, right? You have things like Wicca, like R, scikit-learn. Things are much more accessible for people, much more easier. And as well, lots of data. It's like a kid in a candy store, right? There's GHTorrent, there's a data track, there's a lot of replication data out there, there's a promise repository. So, we're really in a wonderful time in our community when it comes to mining data and looking at data and empirical evaluations in general. So then versus now, there's a huge difference. How did we get there? Well, it was a huge community effort, right? Many of us worked on making this happen. Many people cleaned up data. Many people, taught people how to do stuff. So really the community, we're standing on the shoulders of many people that came before us. However, it was all that in mind, there's still, I would say, a low practitioner interest in our work, low practitioner participation in some of our venues. And that's something that's not just within the ICSME community, but it's across many of the communities today. And that's, for example, ICSE, when it was in Montreal, I was the chair of the industrial program. And the whole idea of the industrial program was trying to bring in more practitioners to attend ICSE. Something in the past was the norm, right? So there was more practitioners, more industry people attending, and less academic, and now it's 100% inverted, right? So the question really is, why is that happening? Especially when you think about it, that when we talk about our reviewers, the amount of rigor in our reviewing process, the amount of feedback reviewers happen, the amount of expectation, and the bar is quite high, right? So why does that happen? Especially when it comes to this idea that we've really raised the bar in evaluation. So you think about, now in the past versus now. In the past, a lot of the studies had no validation whatsoever. They were more kind of ideas. Then we went, the single system validation, multiple systems, GitHub scale. So it's not, unheard of where you can have a study that had looked at 10,000 systems, right? And now even we go to this idea where we've done these user surveys. Sometimes I joke that the ICSE, which is the International Conference on Software Engineering, is almost sounding sometimes like the International Conference on Survey Engineering, right? So the rigor is going higher and higher. The pendulum have shifted from one extreme to, I'd say, to another extreme. And the question is, what's next? And this is my concern, right? The concern is, are we really going in the right direction, or we're just walking off the fall off a cliff? So the point of today's talk is really to talk about this point, to raise awareness and to start a discussion about, are we on the right direction, or should we really rethink how we're approaching evaluations and validations in software engineering in general. And why should we do that? Because when we look today at some of the research areas, they've already almost died, right? Or just have stopped growth because of the rigor and the expectations of the evaluations that our community expects today. So two of the most well-known research areas, things will be like program understanding software visualization too. And in my opinion, these are very important research areas. They do have an impact on practice. Practitioners do need these type of work, but getting that type of work published in a top venue is harder and harder, if not almost impossible. I do know that VisSoft just wrapped up, a few hours ago, but the reality is that today getting a visualization paper accepted at a top venue is really, require an enormous amount of work, and that shouldn't be the case, right? And it comes down to the rigor and the expectation of the evaluations that we're putting on all the research in our area. The other problem too is because we have put so much rigor, so much expectations on the research evaluations, then we're almost coming to the state where the research is driven by the availability of the data instead of the challenges at hand. So it reminds me of this, there's always a joke about some guy lost his keys in a dark alley, and then when he comes home, he's looking for the key there, and his wife asks him, how come you're looking for the key there? And he says, oh, because I lost my key in the dark alley. And she's wondering, but how come, why you're here? He says, well, here there's better light. And that's exactly where we're at right now. There's so much studies happening in empirical software engineering and in general software engineering. And to make sure that we have good data sets, we go out to open source projects. And a lot of the open source projects are kind of systems projects, right? So operating systems, databases, a lot of the data center kind of work, right? So we end up in our community missing a huge part of software in general today out there, right? Things like IoT, cloud computing, web apps, machine learning, AI-based software systems. So all these systems, just because we don't have access to the data, that now software engineering has just really become software engineering for open source, and a lot of times. And that really comes down was the bar is so high on evaluations. So really, in my opinion, we're doing this ourselves, and we need to think deeper about what's the next steps for our community. Do we want to continue down that path, or we need to rethink our work and our directions? And to kind of structure today's talk, I'm going to be kind of touching on 4 things. So this drive for generalization. So, we want to have findings that hold across any possible system we can see. I call that the N+1. So if you have 10 systems, reviewers want to see 11. If you have 50, they want to see 51. If you have 10,000, you want to see 10,001. Okay? This push for always having replication data, while it's a good direction, but I think we need to figure out, there's a lot of nuances about that push for the replication data, and whether there are other things that might be lighter of an ask with as well as a big of an impact and a value for our community to move forward. Another issue is this idea always about what exactly is a software engineering paper. What is the definition of software engineering? Is looking at cloud computing paper, programming, software engineering thing or not? And practitioner buy-in. This idea that we always need to have the practitioner on board and having their kind of thumbs up that what we're doing is relevant to them. So let me talk about the software engineering issue, right? So a lot of times we see this is a kind of almost a classical way to reject the paper. This is not software engineering. So we have seen that early on. It was for mobile apps, logs, build systems, cloud computing, NoSQL systems, and the next is going to be IoT systems, right? And that is a problem here. So give you an idea, and so these are 2 examples, right? So this is some of my group's work where we have like a desk reject from TSC. So this one of them says that cloud computing is outside the context of TSC, and blockchain, we're recommending, like a desk reject. Now, for somebody senior as me, this is okay. This is not a problem. We can move on. But now for the students, for the junior faculty, the people that really we want them to kind of push the boundaries of our research area, they become much more worried. They don't want to go down these little corners, right? They really want to stick in these, what do we call them, safe pockets, right? So open source stuff, right? Apache Foundation kind of software systems. Now, is this the right direction we want to push the community? Or should we really be encouraging, innovation? Should we be encouraging risk-taking? Should we really be saying, well, there's software, there's code, that code needs to be maintained, people need to develop things around that, That is software engineering, right? Now, our community is not the only community that has this problem, right? Other communities have that. I think one of the nicest one is the SIG IR community and the story of the Google paper. So the Google paper, when it first was submitted, it was submitted to SIG IR and it got a rejection, and the rejection said, look, you need to stop talking about this web analysis stuff. There's nothing, this has nothing to do with information retrieval. Now, fast forward, now we know that pretty much almost every information retrieval today is driven by a graph and the network and that web kind of connectivity of the whole internet. So this idea of this is software engineering, this is not, this is information retrieval, this is not, is a really, at sometimes it feels like a very easy decision to decide on, but I might disagree. I mean, this is really at the core of where do we want to see our community in the future? Do we want to be focused on the old stuff, or do we want to be focusing as well on the upcoming and interesting topics? Now, the other thing is there's more studies. So this idea is that our goal here is just full generalization. So the best example of that, I'm going to use a kind of a medical analogy, is you come in and you have a paper that says, oh, we can early detect brain cancer. We can even cure it. And, the rejection will come in the following, well, but you can only do brain cancer. How about skin? How about lung cancer? Now we laugh about this, right? We say, that doesn't happen. But that's the reality, right? Today, if you publish a paper and you say, look, based on our study, based on our technique, we can improve the productivity of a software developer in the Microsoft Word team by 10% or 50%. We do know that one of the comments that will come in is like, yeah, but that's just generalized. But the deeper question is, do we really care about generalizing it? Can we actually ever generalize, right? Having looked in this area, in the research area for many years, I can tell you that generalization, is going to be very hard in our field. And the reason is software is very malleable, right? There's so many things that cannot change in a project, but the software is one of the things that could change. Second, there's always human in the loop. And whenever there's people, it's very hard to predict them, it's very hard to understand them. So with these two things in mind, really generalization becomes a very tricky business. And one can start wondering if that's really the ultimate goal of our field. Okay? So, and this is the problem with that, is just getting to the state where we always want more systems. So here's a funny analogy. So in 2013, at ICSME, we submitted a paper and that paper we had, at that time, the Google App Store was small enough that we crawled every app in the store. And when the student came to me and said, don't worry, man, this N+1 thing, we're not going to have to worry about it because we have everything. But in reality, we came to the reviewer and said, oh, well, I need to figure out a way to give you an N+1 reply. So mobile apps, the inverse of them is static apps, or, what I call stationary apps. So have you dealt with stationary apps? This paper is no good. If it's kind of obvious, should be rejected, right? So this kind of blind search for this N+1, this generalization, is causing a lot of risks and threats to our community. First off is we're really now having the state where researchers are really encouraged and pushed to have as many systems as possible, but not just that, as many systems as possible that satisfy and prove their point. So if you have 10 systems and 2 of them are not fitting the model you derived, instead of going down and digging why, instead you would drop these 2 and you'll go get another 2 or another 10 that match your findings. Okay, and that will make the reviewers happy, because as soon as you find things that are not generalizable, then the reviewers come in and say, well, look, that's not generalizable, so this is of little value. But the reality is software has a huge impact on our world, right? All the way from systems, kind of software system, then you have mobile apps, they have IoT, you have set-top apps. All of these have different needs, different expectations. The software runs in your car. So expecting something that will cover everything is not realistic. And instead, we really should encourage that diversity and encourage people to really not tell us what works, instead tell us what didn't work. What are the software systems where this finding didn't hold. So my feeling is if you have 10 systems where everything matches, I don't think you've searched hard enough. So the answer shouldn't be, I want another 20 or 50 systems. Okay, so we need to kind of go away from that N+1 thing. And as always, as you add more systems, well, there's limited time, so now you're not going to be able to do deep analysis. A lot of the analysis is going to be shallow. Okay, so really what I believe the key point I want to push here is we need to be looking for the generalization of the approach systems, instead of generalization of the results. And why that's important? Because practitioners today, what they're looking for is they're looking at these findings and look, okay, this worked for Windows, Office, this worked for this little mobile app, right? My company is a big company, is building a mobile app. So, I might be in the middle between these two. I might be more on the Office side. So by looking at results that are, by them looking at the approaches themselves and understanding how they can apply their approaches and make it accessible for them to apply their approaches, then I feel there's a much easier probability, there's a higher probability that we're going to have more tech transfer and more kind of value being provided to practitioners today, instead of just as trying to have, kind of belittle findings that hold for maybe 1 or 2 systems and say, well, if it holds for a small amount of systems, we don't care. Now, I'm not saying have all little toy projects and show that things hold, but big systems are of value, and it's, one system that's serving millions of people or thousands of people does have, it is something that is worth studying, and we can learn a lot from it. Now, other ways other communities have looked at it is they've looked at this kind of meta-analysis, right? So many studies done by many different people over the years, and then the results are combined. So this shows you a study where they were trying to decide whether it's valuable to take an antibiotic or not for this disease. And every study, there's a dot and there's a bar. The bar is a confidence. And then there's one big line that goes across, and that line is just telling us, if you're on the right side of the line, or if one of your confidence bar crosses it, that means that it's an inconclusive study, okay? So you can see, for example, the first study, it was inconclusive, right? Now, later on, some studies, it's more all on the green side, right? Now, another way, so this is, you can see here, there is many studies. Some of them had as little as 15, individuals. Some of them had 240 plus individuals. In total, there's over 2,500 individuals. So now you can do this cumulative analysis, right? So early on, we still had this thing where it was unconclusive, but as more and more studies started being done, and we're integrating the results and the statistics from the prior studies, we're now much more conclusive, and the confidence interval you can see getting smaller and smaller and smaller. And we have a much more kind of solid understanding of what exactly is the true impact of using an antibiotic for this type of disease. So, and in this case here, started from as early as 1971, where people started saying, okay, yes, there is value to do that, and this is possible by doing these cumulative studies, right? But it's these meta-analysis, right? Where right now every study is looked at it separately, and all we're caring is just the quantity. I don't think we're really building, a body of knowledge, right? We just have many studies, and where the N is getting bigger and bigger. Where here the size of the population is not growing out of control, but we are looking and leveraging the prior findings of the prior studies. So really, the key point here is more is less. Right? We're in a world here, we have a lot of big data. So I'll call that rich data, right? This is really where we need to be looking more and doing our studies on these rich data sets. Okay. Now, another thing is this practitioner buy-in. Now, I'm gonna do the same analogy, this medical analogy. So imagine somebody comes here and says, smoking kills. Right? And we have a study that shows that smoking kills. Now, a software engineering reviewer would come in and says, but did you talk to the smokers, right? What do smokers think? Do smokers agree with your opinion? Well, I'm hoping that you do see that this doesn't make a lot of sense, right? Or what did you think? What do doctors think of that, right? Maybe you should go talk to doctors because they're the experts, right? You did this analysis, and maybe did they find that analysis surprising? Well, there's somehow this expectation that a practitioner is all-knowing and way more experienced than us and our analysis. Now, let me show you some interesting, right? So this is a study that was done in the New England Journal of Medicine, okay? And they found that 55% of the time, patients did not receive, the recommended care for their condition. And now when we even look at, the computer science and, community and developers in general, so looking at Stack Overflow survey in 2016, what they found that less than half of the developers have a CS degree. Okay, and actually, even when we look at Coverty, which is a good example of practical research, academic research that has been moved into practice and extremely popular and very successful. And when they sat down and they had the kind of looking back about what they learned and what they didn't learn, one of the first and the top things they learn is that initially we thought that if you actually do code, okay, for money, and this is your job, that you will understand things, right? But in reality, a lot of times, people say, well, to build something, I just click here, right? And, in general, what they found too is some of their most sophisticated kind of static analyzers, they even had to comment them out because it was too complicated to explain to their users, okay? And, even much closer and more recent here, so we went out on a study and we said, okay, let's go around and ask developers what their opinion is of things that we know very well about, right? So one of the things we know very well about is, as you know, one of the big areas of empirical research is bug prediction and defect kind of predictions, right? So we wanted to ask people, okay, what do you think is the defect distribution across your code base? So do you have a small amount of files that have a lot of bugs, and then the rest of your files are pretty flat? So that we call that a long tail distribution, or is it more of a normal distribution? So you have a few files that have a lot of bugs, you have a few files that have little bugs, but most of the files have average amount of bugs. So that is a normal distribution, or uniform. It just everybody has the same amount of bugs independently, okay? And you can see here from the study that 48% of the respondents said that we expect to be a normal distribution. Now, the correct answer, and that's something that, even though I said that it's hard for us to find general findings, but this is one that we know for sure today, that around 20% of your code will have 80% of your bugs. So it's a long tail distribution. So you can see here that practitioners got it wrong, right? Not only that, so when you talk to junior developers, they got it way wrong, right? So they're thinking 73% of think it's a normal distribution. And even when we look at senior developers, only 43% of them got the right distribution. And so that is a kind of a warning about, developers don't know everything, right? They're actually coming for us to tell them about things. We shouldn't always expect that they know everything and they know what's best for them and know what is the most accurate and appropriate manner to go about things. Okay. So now, even with that in mind, so maybe you say, well, how about if developers, do they agree with each other, right? Independent of whether they're right or wrong, do they even agree with each other? So in this case here, we went out, it's part of the same study where we surveyed 400 developers, and we asked them, okay, do you believe that a file that has more commits is likely to have more bugs in it? Now, this is a well-known thing, again, in defect prediction, and the rationale is very simple, right? You might have the most complex code in the universe, but if that most complex code never changed, it doesn't rot. It's not suddenly bug starting appearing in it, right? So that's exactly the situation here. So as soon as you touch it, the chance of adding bugs increases quite a bit. Okay, so this is a well-known thing, but in this case, only 46% agreement of the 400 developers that we surveyed agreed with this point. And then we looked at the kind of, I would say, the conflict, right? How controversial the statement was. So we looked at the strongly agree, strongly disagree, strongly agree versus strongly disagree and disagree. We compared these two, and you can see it's almost 1-to-1, right? So it's like 2.3%, right? So it's really like it's bipolar. Either people are really on this side or this side. There's really not a lot of people in the middle of this, right? So they're not agreeing with each other, and they're not agreeing with what we know today for a fact, really. Okay, and now, does this really make sense to go and ask these people for feedback about their impact of what we're doing next and whether what we're doing next is valuable to them? You got to realize that a lot of these people, their key point is just to get the code out of the door. They don't have time to do that deep thinking. They don't have that time to look forward. This is really the job of our community, and sometimes we need to take risks. Sometimes we need to say, look, this is a promising direction, and we need to go down that direction. Even some practitioners might think there's a little value in it, but I do believe there's value to do that, because that's exactly what research is about, is high risk. And even then we said, okay, maybe the reason there's this high disagreement is because, we're bringing researchers from very different contexts, right, across the world, asking them these questions. So instead for this, we went to Japan now, we went to Sony Mobile, and we did a similar study working with the Sony Mobile team. And in this case, we were focusing on some of the best practices that we know about code reviews. So we sat down, we did this kind of workshop. We brought 93 stakeholders, we surveyed them, we told them, what do your opinion are the best practices, the best values out of code reviewing? So then we got these lists of things, that they believe are important. We then kind of went through 15 engineers, we kind of narrowed down the list. Then after that, we did that post kind of survey where we went to 25 senior engineers and asked them whether they agree with these final statements that they came out. And at the end, we had these statements that everybody in the company kind of agreed on. Now, surprisingly, at the end of it, the agreement rate was around 68%. So for every 10 statements, 3 of them people disagreed on, even at the end of this whole process. And why is that? It's just because there's a big variations, right? And variations come from different reasons, right? So really, context matters. Now, what do I mean by context? Context comes in what you're working on, right? So the people working on the kernel, a kernel panic is a bug for them. People working in the UI, a UI typo is a bug for them, right? The own experience, junior versus senior, right? Prior systems you worked on. So the area, the domain is very large, and just trying to find a small set of users that will give you that go ahead on the piece of work you're doing, or the value that piece of work you're doing. And if you can't show that, you can't demonstrate that, then that work is something we shouldn't pursue. I don't think that's the right direction that we're going in. Okay, so yeah. Now, the next one is this idea, this validation, a replication of data, right? So replication data. So many years ago, people would do their studies, would publish the results, and the data is not available. Nobody can go back, reanalyze the data, okay? Now, I think replication data is a great step in the right direction. But at the same time, I think there's another step we need to take, and that step is, I believe, lighter and as impactful as replication data. And it comes down to going back to what I said. Today, when it comes to mining data, there's access to a lot of tools. A lot of these tools are quite complex. And if people don't have a good understanding of the data, then guess what? We're dealing with a ticking bomb, right? People have things that they don't know how to use, and they're using them. They're getting results, they're getting conclusions, and we're going on from there. So here's a great example, of the risks that come in. So we looked recently about some of the work that they try to take a commit message, and from a commit message, they take a commit and they're trying to generate a commit message. So prior work created deep learners that will take a lot of prior messages and a lot of prior commit messages. And now when you get a new commit message, a new change, you will try to generate the commit message for that change. Okay? So, and they perform relatively well. But we said, let's step out for a minute. What happens if we break something very simple? Just a nearest neighbor algorithm. So we would take the new change, We would search at the 3 closest changes to it, look at their commit messages, and we take these prior commit messages, merge them, and we make them the commit message for that change. And surprisingly, this performs extremely well, right? So the key point here is that today there's this crazy drive for more and more complex technique, crazy drive for all these deep learning techniques. But in reality, and this is something we observe as well emphasized by Tim Menzies and his team at NC State, is that we really need to think really whether we need to bring in a rocket launcher to a kid's day, kid's birthday party, right? We need to really bring the right tool, and the simpler the better the tool, really. So that's something we really need to be very careful about, because as well, if the technique is complex, it's hard to explain it to practitioners. Second is, we don't know if we're using it right. We don't know, and if even you know how you're doing it right, your students, your research team, you know how confident you are about that. Okay. And let me show you a very simple example. It was a very simple technique. No deep learning, no crazy magic, right? And to show you how risky this is. So in this case here, we're going to look at logistic regression. So logistic regression will take different metrics, and then we try to give you a probability of something being true or false. In this case, we're going to use it to try to predict whether a file is buggy or not based on some properties of the file. So in this case, I'm going to build a model that said whether a file will be buggy or not is a function of the lines of code and the cyclometric complexity of that file. And now I want to emphasize something. We're not really trying to predict bugs the same way people not trying to predict whether you're going to die with cancer or not. Really, our real interest is not the prediction, but it's looking at the variables and trying to understand what are the ones that have the most influence. Then if we can control these and improve them, for example, we discover that complex code is a sign of high problems, of problems, then we could ask people, for example, to refactor that code, right? We can develop tooling around it. So really our key point here is to have an empirical testing, empirical understanding of the phenomena so we can react to them in a systematic way, okay? So here's a simple example. So I'm going to build 2 models. In the first model, I'm going to put CC max, which is maximum cyclometric complexity, as the first variable in my model. In the second model, I'm going to put it as a second variable. Both models, I'm using the same exact metrics. Okay? And then now I'm going to look at how these models perform. Okay? Now, CC max is maximum cyclometric complexity. CC average is average cyclometric complexity. These 2 metrics are very highly correlated. Okay? Now, when you look at the models, so the AUC tells you the quality of the fit. In this case, both of them are really good fits. 0.5 AUC means it's random guessing. 1 means it's perfect. So the fit here is good, and it's the same fit because we're using the same amount of data, right? Now, the next step here is to understand what's happening. And now if you look at the model, so there's something called an ANOVA, and ANOVA will give us how much every metric is contributing into that model. And if you see in model 1, CC max is contributing the most, okay? And CC average has almost no contribution. And then in the second model, it flipped. So now what used to be the most important contributor is no longer the most important contributor. And we did nothing. We didn't change the experiment. All we did is we flipped just the ordering of the variables. Okay? And this is exactly the situation we're dealing with a lot of times, right? So this is so bad that I can create my own metric. I call it Ahmed's cool metric, which is 3 times CC max. I'll put it on the front of the equation, and suddenly you're going to look at me and say, wow, this Ahmed is such a smart guy. He created a new model, and he created a new metric, and that metric is outperforms all metrics known to humankind. Okay? That shouldn't be the case, right? So now this idea of looking at correlated metrics is something that we need to look at, right? They need to be removed from the models before we do analysis. How many people do that? Very, very few. At one time, we looked at this. We looked at data back, 10 years, and we found that 60% of the studies didn't at all talk about correlated metrics. So this one risk in there, right? Here's another risk. So people know about precision and recall. Now there's another metric which is called F measure, which is the harmonic mean or precision and recall. And F measure is usually used to judge, whether whether one technique is best than another, or to basically kind of order things in experiments, right? So here you can see this is the same experiments, but what people don't realize is an F measure has inside of it a threshold. That's the threshold that's used inside the logistic regression model, because the logistic regression model just gives you probabilities. And then if something is above a probability, you could say buggy. And if something is below, it's not buggy. So now if you can change that threshold, you can change the story. So in this case, we're trying to decide whether logistic regression is better than random forest. In the first graph here, you can see that logistic regression is better. In the second graph, random forest is the better. And in the last graph, the third graph, they're the same. So really, you can tell me what conclusion you want, and I will create the summary for you. If you want them to be better, one better than the other, I can do that. If you want them to look the same, we can do that. Again, this shouldn't be the case. Now, is this a problem? Yes. Is it happening in our community? Yes. Now, is this only our community? Well, not really. And this is the key other point I want to highlight, is that I'm highlighting issues, and these issues are not only specific to our community. So here's an example. So we looked at KDD, which is one of the big data mining conferences. We looked at the papers in 2017 and 2018, and we found that 85% of the papers never talk at all about the threshold that they use for the F measure. So we don't know what threshold to use. And even more alarming is the 15% that do talk about it. So they mention a threshold. So the question now comes up, did they tweak the default threshold to get the conclusion that they want? Okay. So these are serious problems when it comes to this whole analytical model. There's a lot of pitfalls, right? There's pitfalls that comes how you specify the model and you construct it. So one of them was the example of the correlation analysis. Other ones is how you validate the model. So this threshold that I was talking about the F measure is there, and as well how you interpret the model. And today, this in many ways are, I would call, bugs and code smells in machine learning code, machine learning programs, data mining programs. Now, is this software engineering? I would say 100% this is software engineering, but now you go out and you start asking, well, is this really software engineering? And these are the questions we shouldn't be asking, right? So we need to go look outside of our community. Not everything is about open source. Not everything is about system software, and not everything is based on the availability of the data sets we have. Okay, so how would you go in there? So I think one of the key things here is this idea of open scripts. So what do I mean by that is we don't actually need the data. What we need here is we need to have a very clear documentation and a runnable script that says, if you had this data, this is how we went through to generate this graph. This is how we went through to generate this model. Why is that? Because it will help our community become better, right? By people looking at code, improving the code, reusing it, refactoring it, understanding it better. Okay. Another key impact too is this works even for industrial data, and it works two ways for industrial data. One, if you're an industrial company and you actually did a study, you don't have to give the data, but the scripts you should be able to give them, right? Because the scripts have, that's really the paper, but written in code, right? So in many ways, when people talk about infrastructure code, so this is, you can think of that analysis as code, research paper as code. Okay, so this open scripts is kind of like that. Second is, today an industrial person, a practitioner, they don't really want your data. What they really want is they want to be able to analyze and run the same analysis you did on their own data. So the key thing here is to be able to give them these scripts so they can do it on their own data. And overall, ensures this whole research transparency in everything we're doing. So with that in mind, and I'm going to wrap up now. So really, I talked about a couple important things today, is this idea that we need as a community to figure out how we can have a bigger impact, right? A lot of times we go down in these corners saying, this is not software engineering. Oh, we need to have a large amount of the data points And because of all these limitations we're putting on us, I think it's hindering where we're going in the research field. Okay, I think in particular when it comes to this generalization drive that a lot of reviewers want, is they want the results to be valid and generalized to every single thing. Instead, in my opinion, I actually want to find everybody's special, as they say, in their own way. And I think the interesting thing is not the things that generalize, is the things that generalize relatively well, but in places they break, we need to understand why they break. Because the reality is we're never going to be able to have full generalization no matter what. Member software is very malleable. There's a human in the loop. So we're really dealing with something that is very hard to model. We're not only modeling software, we're modeling organizations, we're modeling people. Okay. Other thing I push forward is this idea of open scripts. So not only replication data, but the scripts are important, maybe even more important, right? Now, full replication packages are great as well, but the scripts, in my opinion, are a key component here. And then the realization that context matters. A lot of our results need to really be put in context. And it is important to have the same study replicated in different contexts for us to understand where some things do apply and generalize, sometimes they don't, and why they don't. So I hope at the end of this, I didn't really scare you about, empirical evaluations and that there's a lot of threats around them and a lot of risks around them. Instead, really what I want now is I want to look a bit further and see what is next. What can we do as a community to move forward? So I do believe we really need to become more risk takers. As a research community, our risk aversion is very high. We don't want to take risk. We just want to do the same stuff that's worked before for us and for our grandparents and our grandparents, right? I don't think this is the right way. I think we need to look beyond that. We need to encourage risk-taking research. We really shouldn't be talking about, is this software engineering, is this not software engineering? Now, I know the SIP track at ICSE tries to do that, but at the end of the day, these are considered to be short papers that are even considered to be lower quality, right? And in my opinion, these papers, these risk papers, should be part of the regular tracks and should be really discussed and reviewed with that in mind. And every paper that needs to be that considered in mind. Today, when you have a paper and you're looking at it as a reviewer, and there's a lot of arguments about the paper and somebody saying, this is not useful, who would use this, that's the paper that needs to be accepted. Because the same way that paper generated discussion between the three of you as reviewers, that's the paper that people want to come in to the conference and see, right? People want to come to get inspired, whether it's academics, whether it's researchers, whether it's industrial people, right? An industrial person will not probably be excited to come on a conference where we say, you remember the problem you had 4 years ago? We now solve it and we solved it so well. Their question will be, well, if that problem was important enough for me, either I 100% solved it, at least for my satisfaction, or B, I'm no longer in business because that was an important problem. I'm here to be inspired for what's next. Okay. The other thing is we need to be very careful because the analyses are becoming much more complex, and because they're considerably more complex, we need to be very careful about how they're done and the kind of outcomes out of them. Okay, and this drive for generalization is not really the right direction. Our goal is not to generalize. Our goal is to help developers, to give them techniques and processes that are generalizable. Sure, some of the results could be as yardsticks, as kind of, here's baselines to work off, but that's not the goal. The goal is techniques that people can take and apply in their own context. Okay, so that's a key point I want to highlight. And then finally is this realization that industry is a partner in this. It's not an idol. It's not if industry says this is not zero value for us, then we shouldn't pursue that, right? Instead, they're looking for us to inspire them. They're looking at us to guide them. And yes, we should listen to them. And yes, we should come and try to work on problems that are relevant to them. But as well, we should work on problems that we believe is useful for them. And maybe today, because they're so busy with their deadlines, they don't see the value. But 3-4 years down the road, they want us to be there. And we have solutions that will solve their next problems. We don't want to say, well, we were waiting till you guys to find a problem for us to come back and help you with it. Or to us to accept, that we're doing is actually relevant for you. Okay, So thank you so much for your time, and I'm happy to take any questions. Okay, have a great day.
Thank you. Another thing that's lost in the virtual conference is the applause at the end of the talk, so I will applause. Thank you, Ahmed, and let's open it up for questions. And you can unmute to ask questions directly. If you do so, please also turn your video on, or you can ask them on chat and we will relay them.
Hey, Ahmed, nice talk. Thanks a lot. Peter Rigby here. I definitely agree with a lot of the points you make, but I also feel that we as a software engineering community kind of get stuck in solving the same problem over and over again. And personally, I feel like when I do talk to developers, often the problems that they're having on a day-to-day basis tend to be quite different from the ones that we're actually solving, right? And I think in my experience, like starting with a problem that they have and then kind of working more to a theoretical thing and coming back down to actually solving their problem can be really helpful. What's your perspective on that?
Ahmed, we can't hear you.
Wait a minute.
Now it's good.
Now it's
Now
good.
it's good. Okay, good. Okay, so I agree and disagree at the same time. Okay, so I'm gonna agree on the part that I think it's good to talk to developers, and I think it's good to work with them to figure out their problems and help them with them. But sometimes as well, there are problems that they might not recognize, right? So a lot of times I would work with collaborators in industry, and they would say, "This is our problem, and we're gonna fund you on this problem." And I would say, "Sure, give me the money for this, but you know what? Can you please let me work on this as well?" And then a year in, that problem that was hot because some manager was on their case is no longer gone. And now the real problem they recognize is the problem we're working on, right? So I think it's good to, well, we should always have them in the loop. But the fact is, I'm saying is, if they don't think it's important for them today, it doesn't mean we should shut it down. I guess the nicest example there would be like the whole deep learning stuff, right? So, you know, at one time, nobody was funding this work and nobody thought it was important, but some people continue working on it, and this is where they are today. And the way our community is designed, it kind of discourages doing things that are not like the classical kind of sessions that we slot them in a conference.
I agree with you. I often feel that developers are often stuck like in their sort of day-to-day what they're trying to solve. But I feel like I do appreciate having a grounding in the problems that they're having. And often because as a researcher, you have the ability to sort of go more abstract and spend more time thinking about, you don't care about today's bug. But I find that in the software engineering community, I see a lot of work that just kind of spins the, you know, yet another bug prediction model or yet another whatever, right? And I feel that developers have helped me kind of say, okay, this is their problem that they're having. Now, maybe they don't even realize it, but at least I've seen it, you know, somewhere in practice, right? And I don't know, I feel that there's a huge amount of value sort of coming at it from that perspective. So anyways, I agree with you, and I guess I also disagree.
But I agree with talking to them, but the problem right now is whenever you find a new problem, you would end up spending almost half of the paper convincing the reviewers that this problem is worth investigating, right? Whereas if you have this shield of 60 citations, which makes it an area that we've been down to death, then suddenly, you know, the paper acceptance probability skyrockets, right? And that shouldn't be the case, right? It should be if you have a problem that some people think is important, that's already good enough for this to be shared in the community. So yeah, thanks.
Okay, we have time for one more question before we have to split off to our technical track sessions. Maybe I'll ask a question. Ahmed, what's the advice for students or people that are trying to prepare a replication package in a double-blind submission field when people, you know, it's harder to have your scripts and your code double blinded. So do you have any advice on how that could be made easier?
So I guess, so this is a great example of this whole double blind thing becomes kind of awkward, right? Because it almost becomes a barrier, right? So I think one of the things that could be possible, and I think some conferences do it, is after the paper is accepted, then you kind of announce who the people are, and it just moves us faster as a community moving forward. So that I would say truly 100% double blind replications, I think, is not the right way, but revealing your person after the acceptance and working with people might be a better way ahead.
Sure, some more artifact tracks.
Yes, yeah.
Cool, well, thank you very much. And please all join me in virtually clapping again for Ahmed. We will have 2 technical sessions now. And so the testing 1 session remains in this room, and the methods and environments 1 session will go into room 2. So if you need the link, you can go onto the website, which has the schedule. If you click on that, the password is the same for all of our rooms over the next 3 days. So thanks again, and I will pass it over to the session chair for the testing 1 session.